Hey, welcome back to Math with Patrick. Today is September 24th, and we're solving problem 267 from the Daily Epsilon calendar. And yes, we are joined by Quill today. He'll be helping us out with some of the math. All right, so it looks like we have some information about two variables, x and y. They are both integers. This says x and y are elements of the integers, so they're like whole numbers. They could be positive or negative. This right here is a compound inequality that just tells us that x is greater than y and y is greater than 0. So actually here, we know that x and y are part of the positive integers. That's just because, well, if y is greater than 0, it has to be at least 1. And then if x is greater than y, it has to be at least 2. So both of them are positive, and moreover, x is even more positive than y, or rather, it's just greater. They're the same amount of positive. Okay, knowing that x and y are both positive integers, we can take a look here, and I see two equations. Both of them have information about x and y. And so usually whenever you have two equations and two unknowns, you can solve for both. Now that's not always the case, but that's just kind of a nice generalization. So I know from this setup, we could probably figure out what x and y are. Something kind of interesting is this condition that x has to be greater than y. This kind of suggests to me that there might be other solutions to this system that we need to throw out based on these kind of claims that they're positive integers. But I'm not sure exactly what solutions we're going to get, so we'll see later why these initial statements are important. So this is like kind of a non-standard system of equations here. It's kind of strange to have both x and y on both sides of this equation. But then the second one is kind of simple, just doing x minus y is equal to 21. And like normal strategies would be to like isolate one of the variables. Like maybe we'd isolate this y, like y, if I like add it over here and then subtract the 21, I could just say that y is the same as x minus 21. We would plug that in here and here. And you know what? That honestly might be the easiest thing to do. I have some other ideas of like what I want to do or like want to try, but this seems pretty straightforward. So let's just try this first. So we can use just normal substitution strategies. We isolated the y variable, and we're going to stick this expression anywhere we see a y in the other equation because they are supposedly equal to each other. So we can go like 2x times x minus 21. That's going to be equal to 117 plus x plus, and then another y, but that's just x minus 21. Usually we should put parentheses around here, but if I'm just adding the x and the negative 21, I know that I don't need those parentheses to group those anymore. We could distribute the left side. That is 2x squared minus, oh wait, hold on. Yeah, 2x squared minus and then 42x. And then the right side is going to be 117 still. We could combine these two x's together. And why not? Let's subtract the 21 off of the 117 just to kind of combine our like terms. Actually, I don't know why I'm borrowing yet. I don't need to borrow there. The 7 minus the 1 is a 6, but then I should borrow from this 100 and make this kind of an 11 tens. And that shows me that this number here should be 96. And this looks like a quadratic, so we should probably set everything equal to 0. I do like keeping my x squared, or the quadratic term, positive, so that's why I'm bringing over this 2x over here as a negative 2x, so minus 44x. And then I'm going to bring over this 96 by subtracting both sides by 96. It's now equal to 0. We could divide everything by 2, so we get x squared minus 22x minus, I can't do that in my head real quick. That's going to be a little less than 50. Is that 48, I think? Yeah, okay, cool, because the 8 plus 8 would make a 16. And then here we could just use kind of standard quadratic solving. I'm hoping this is factorable. I'm trying to find two numbers that multiply to negative 48 that add to negative 22. So we could try like 4 and 12. That doesn't really work out. 2 and 24 feels best. And then I should make that 24 negative so that I get this negative middle term. Okay, now we get two solutions, and it's making a bit more sense to me why we have these restrictions earlier. At least this one makes sense to me now, that this helps me rule out uh, this solution of x equals negative 2. Just because they are both positive, this solution is ruled out. And x equals 24 seems like the only one that's left. It's a little bit interesting to me that they are forced to be integers, because as far as I can tell, the only solutions that I have were just integers. So I don't know if that first claim is all too important, but this one definitely helps me find the 24 instead of calling today the negative 2nd of September. So I guess that's it. We're basically done. Actually, yeah, I still need to cross off this answer. If you want to stick around just to see what other stuff we could do to it, feel free. I still am a bit curious to try something here. And it's all about this 2xy that's at the front here. I do know that if we take x plus y and square it, or if we take x minus y and square it and expand everything, we're going to see this 2xy show up. And I just wanted to play around with it and see if it's at all useful. Expanding this top one, we get x squared plus 2xy plus y squared. And in the bottom, we get x squared minus 2xy plus y squared. Again, not sure if this is useful, but we do have this x minus y right here. And I was like, I don't know, maybe there's something fun going on in here. This is the same as just taking this x minus y and squaring it. So this should be the number 441. That's 21 times 21. So 441 is equal to x squared minus 2xy plus y squared. And then maybe we could take this and substitute it in here for this 2xy. I'm kind of realizing that this might not work out so well. X squared minus, and then 2xy. So that's just going to be minus 117 minus x minus y, and then plus y squared. That's equal to 441. I mean, maybe I could make this like a circle equation, but that's really, that's going quite, down a rabbit hole. Is there anything else I could do with this? I guess not. Just to show you what I meant by a circle, we can just keep playing around with the algebra. I'll add both. I'll add 117 to both sides right there, and so we do get 558 equals x squared minus x, and then plus y squared minus y. And then just to give me more room, I'm going to take this down here. 558 equals x squared. Was that minus? Yeah, okay, minus x plus y squared minus y. This right here is a circle, I believe, because we can complete the square by adding on a, what's the best number? I think a 1/4 here and a 1/4 here. The idea is that I can complete some squares. This is going to be x minus 1/2 squared, and then this will be y minus 1/2 squared. And then to compensate, because I did add an extra 2/4 to the right side, we would get another 2/4, or essentially a 1/2 on the left side. And so this also could be a way to solve it, right? We could try to figure out some solution here with this circle and this line. So why not? Let's just port all of this into Desmos just to kind of get a graph, just to see what my kind of crazy thoughts produced here. Okay, I typed it all in and I kept it hidden from myself just so we could see it for the first time together. This to me is obviously a line. I know that one of the points is going to intersect 21 here and 21 there. So, oh my goodness, never mind. Negative 21 there. That's what would have happened if it were x plus y equals 21. Would have looked like that. Whoops. X minus y equals 21 looks like that. This one right here I was claiming was a circle. Its center is going to be at positive 1/2 comma positive 1/2. So right here where my cursor is. And then this right here is going to be the radius squared. So the radius of this circle is going to be about 23. So it'll reach roughly here-ish on the screen and kind of scoop downwards. And then here we do have two intersection points. There is that 24 that matches today's date. This is the value for x that does solve the problem. Also, y is equal to 3. That does make a lot of sense based on this equation right here. And also, it's really good that x is indeed greater than y, because that was a requirement of the problem. I'm kind of extrapolating here, and I know that the second solution is going to be right there. There is another solution, looks like when x is -2. Well, we already saw that, right? X is -2 is a solution that the quadratic produced. And then I guess we could just plug in that -2 into here to show that y should be equal to -23. And zooming out between my circle and one of the original equations from the problem, I don't see any other solutions. So that like initial condition that x and y were both integers doesn't really seem to matter. And here, let's reveal the last one. This equation, I'm not sure what it'll produce. Maybe it's like a hyperbola. Maybe it's an oval. It's okay. I guess kind of, yeah, this technically is a hyperbola, although it does really look just like one of the reciprocal functions with like, a different kind of multiplier here. I'm just kind of guessing and checking until I roughly hit it. So it looks kind of equal to that, although maybe it's not quite as equal as I wanted it to because the left branch isn't quite lining up. Anyways, looks like here all three of these equations are intersecting just those 2 points. We don't really need the circle because like the problem didn't provide it, but I do think it's kind of fun that we could create a different structure that also has the same intersection points as the original two equations here and here. In any case, the answer is 24. That's this guy right here, and we are all done. So thanks for coming along and kind of exploring the rest of the problem with me, and I'll see you tomorrow. Bye.